Now, if you are in class, at the very end of every class lecture, I try to do what's called an attendance question. It's more or less just a chance for you to review the material. So I happen to have an attendance question for this particular chapter, so try it just as a way to review for you. So what I want you to do is I want you to pause this right here and look at these questions. So how many sig figs, complete the calculation and round off to the correct number of sig figs, and are these qualitative or quantitative? So pause it, try these, and then I'll help you with all the answers. So counting sig figs is pretty straightforward. So this first example, we have 7.4. Now we know anything that's not 0 is always considered to be a sig fig. So in this particular number, we have 2 sig figs. Now, zeros tend to cause problems. So in this next number, we have some zeros that we have to evaluate. These first two zeros, 0.0130, those are called leading zeros. Leading zeros, never significant. The 1 and the 3 will be, and then we just have to decide what do we do with this final 0 at the end. Because remember, your trailing zeros are sometimes the ones that give you problems. In this case, there is a decimal in the number, so yes, that trailing 0 does count. That number has 3 sig figs. On the next one, okay, we got lots of zeros in this one. Leading 0, never significant. Captive 0, always significant. Trailing 0, only significant if there's a decimal in the number, which there is in this case. We have 4 sig figs. And finally, 1,630. Now, this one has a trailing zero. So we look at our rule. General rule of thumb is that number has to have a decimal. Now, it might be significant, but we're not told. And because we're not told explicitly that it is, we are going to assume that it's not because there is not a decimal in this number. So for this particular example, 3 sig figs. All right, on this next one, we are supposed to complete the calculation and then round off to the correct number of sig figs. So the first one, we have 17.1 plus 0.77, so 7871. And then what we're going to do is we're going to round off to the correct number of sig figs. Now, when we add or subtract, that's going to go by the number of decimals. So I lined it up whenever I was adding them. I know it looks a little messy. And then I'm going to draw a line. And I know that I need these places right here. Now, the question becomes, this last one, is it going to stay in 8 or does it round up? And remember, the way that we figure that out is we look at the next number, and we're going to go by that general rule of thumb. If it's 5 or above, we round up. If it's 4 or below, we leave it as is. It's a 7, so we're going to round this one up to 17.9. Let's try the next one. We have 47.826 minus 9.4. We always do our math first. Now that we have that answer, we're going to look at the number of decimal places. I have 3 decimal places in 1. So I want to have 1 decimal place in my final answer. So I know I need these 3 places. Now this last one, we're going to look at the next number to see if we round it up or leave it as is. On this one, we're going to leave it as is, 38.4. All right, let's try the next one. 98.76 plus 9.5. Let's see how good my math skills are. There we go. I have 2 decimals. I have 1 decimal. Because I'm adding, I go by the number of decimal places. I need 1. So in this case, I need these 4 places. It's not always going to round to the 10th spot. I know in these examples that I'm showing you, it does. It won't always do that. But Such is the luck of examples. So on this one, I have 108, and then we have to figure out, is it going to be 0.2 or 0.3? When we look at that next number, it's a 6, so we're going to round this up to 108.3. Now I have one more example, but on this one, I'm actually going to use a calculator because I don't want to do this one longhand in front of you because that might be embarrassing. We have 12.4 and we're going to multiply it by 5.3. I do not have enough board space without cleaning all that off. When we multiply those together, we get 65.72, and we have to figure out how we want to round this one. Now here we've changed operations. We're not adding and subtracting, we are multiplying and dividing. So we have a whole new set of rules. When you multiply or divide, it goes by the least significant figure within your measurement. So we look at our two numbers. I have 12.4 that has 3 sig figs. 5.3 has 2 sig figs, so I need to have 2 sig figs in my final answer, meaning I know I want the initial 6 and then I want this 5. But does that place stay a 5 or does it round up to a 6? So we look at that next place, it's a 0.7, so that's going to cause this to round up to 66. All right, that's a few for you to try. Let's go on to the last one. So this last question is going to talk about qualitative and quantitative. Remember, qualitative is just an observation, and quantitative has a numerical measurement involved. So let's try these. On the first one, the grass is tall. Well, how tall is tall? That is qualitative. Qualitative. Sample 1 is a liquid. Now this one sometimes gives people trouble because it does have a number involved in it, but is the number actually a numerical measurement, or in this case, is it just identifying which sample it is? In this case, it's not actually a numerical measurement. This is just saying, hey, that sample over there is a solid. So we're going to say this one is also qualitative. The distance to Edna is 15 miles. That is from Coffeyville. That's how far I drive every day to get to work. On this one, we do have a numerical measurement. We have a magnitude. We have a unit associated with it. This one will be quantitative. Quantitative. And then the last one, it is very cold outside. That does depend on where you're at if it's very cold. That's qualitative. That's just going to be some sort of an observation. So hopefully this gave you a chance to practice a few of these types of problems. And if you have any other questions, let me know.